Satellites provide huge amounts of data, but detecting events such as floods or wildfires quickly is still a major challenge. Since ELLIOT's first multimodal foundation models are still being developed, what progress has been made so far in preparing this use case?
So the idea of our use case is to be able to handle these situations like detecting wildfires or even forecasting them in a better way, as it is being done now. And that means including more modalities, including images from different kinds of satellites and including other ancillary data that could be useful for this task. And in that regard, there are two main axes along which we are moving. One of them is gathering the data necessary to solve these tasks, and the other is developing the models. And in both axes, we have had quite a bit of progress. In one of them, we have started with the development of a major tom ELLIOT pre-trained dataset, which is a huge dataset with more modalities or more kinds of satellites than has been ever before used, and also with time data, which most of the pre-training datasets so far didn't have. And on the other axis, we have been trying to adapt existing Earth observation foundation models and trying to improve them.
What has been the main challenge so far?
The main challenge regarding the models would be that most of these models, even though they are open source in weights, they do not have the training recipes openly available. So just replicating the results is already quite difficult. And in terms of data, the problem is that gathering this data is not easy. It requires a lot of expertise, but we're moving along quite a bit along both directions, and it's going quite well.
To predict climate change more accurately, we need detailed information about the Earth's surface over long periods of time. How have you progressed in using multimodal foundation models to recreate complex land surface conditions?
One thing that is important for climate modeling that specifically for land surface is that it comes with a huge uncertainty compared to the other component, for example, an ocean component, atmospheric component, land comes with lots of uncertainty. And our hope is by going towards finer resolution models, it can reduce the amount of uncertainty in this representation. And one of the goals of ELLIOT is, can we bridge this resolution gaps? Because most of the models for climate models runs on maximum. The finer resolution is around 25 kilometers, 30 kilometer resolutions. We want to take the steps to go to kilometer scales. And the idea with ELLIOT for our use case is, can we bridge this gap by using foundation models and also a lot of ancillary data sets that we can close this gap.
Looking ahead, what needs to happen next so that you can make long-term climate predictions more reliable?
One thing that we are aiming for is quantifying uncertainty, which is one of the main challenges in climate change. And that's one thing that we're trying to go. The other is this potential multimodal capability of it, so we can connect it corpses and research materials that exist, reports that came out, and maybe we can use them to reinforce our finding and be more reliable.